There's one principle underneath every episode in this series. It's called the Principle of Least Astonishment, and it says, a system should behave the way a reasonable person expects it to. For an HTTP API, that means a caller, a developer, a script, or an AI can predict what your endpoint does without reading your source. Every RFC we've covered is just that principle written down. So for the finale, let's see what it looks like when you ignore it and when you don't. Here's the creative API, the one that does everything its own clever way. It returns 200 OK on a failure, hiding the error in a field nobody checks. It returns 200 for a thing that doesn't exist. It lets the last writer silently clobber the first. And it invents its own pagination header that no client library understands. None of this is wrong. Exactly. It works in a demo. But every single choice forces the caller to read your code, handle your special cases, and get surprised in production. Astonishment everywhere. And here's the same API built on the RFCs. A create returns 201 with a location header pointing at the new resource. A missing project returns 404 with a standard problem details body, not a guess. A conflicting update is refused with a 412, so no one's work is lost. And the next page is an RFC 8288 link header that every HTTP client already knows how to follow. A caller who's never seen your code can predict all of it, because it behaves the way the standards say it should. That's the whole game. Look back at the whole series, and it collapses into 3 promises. Errors that explain themselves, problem details, a semantic status catalog, field-level errors with JSON pointer. So a client always knows what went wrong and where. State that's safe, e-tags, and if match. Conditional get with 304, idempotency key for retries. So concurrency, caching, and network hiccups never corrupt anything. And growth without surprise. Prefer cursor pagination, namespace versioning, and rate limiting with retry after. So the API can change and push back without breaking a single client. 10 episodes, 1 idea. And here's why a framework matters. Knowing the RFCs is one thing. Doing them right, on every endpoint, under deadline, is another. The point of Trellis is that the RFC-correct path is the default, not a best practices doc you have to remember and reapply. The compiler and the analyzers catch the common mistakes at build time, before they ship. That's what compiler-enforced guardrails for .NET means. You write the handler. The predictable, standards-correct response is what falls out, for every caller, whether it's a human, a script, or an AI. So that's HTTP APIs by the RFCs. 11 episodes, 1 principle, don't astonish your callers. Use the status codes that mean something, the headers that already exist, and the shapes clients expect, and let the framework make that the path of least resistance. Thanks for watching the whole series. If it made your APIs a little more predictable, subscribe, there's more Trellis ahead. I'll see you in the next one.